Today we will discuss how raw data is classified and tabulated. Data can be collected through experiments, observations, counting, measuring, or even through interviews we can collect data. We can conduct surveys to collect data. So that is the first step. So we get raw data out of any of these methods. And thereafter, we have to organize this raw data into a meaningful and comprehensive form. That is what is called as classification, which is then followed by tabulation. So it is the systematic organization of raw data in a comprehensive form. So the first step is classification, where we classify or categorize data according to certain characteristics. Thereafter, we will tabulate it. That means we will systematically summarize this classified data in tables arranged in rows and columns. So we will go to some examples. So here we have three individuals, Sam, Anita and Henry, whose blood parameters are being checked. So they were given a medication to improve their blood parameters, and the values were checked on day 1, and after medication of 30 days the data was again collected on day 30. So we are just studying the effect of that particular medication on their blood parameters, and here various aspects of blood have been collected, that is the HB count, the RBC count, the WBC count as well as the platelet count of all these 3 persons on day 1 as well as day 30. So all the observations are here, but they are arranged in an unorganized manner. It is not arranged in a systematic manner. Every data we collected is here, but it is not systematic. So next what we do? In the next step, we can see that this data has been summarized into a table, where we can see the names of these 3 individuals occupying 3 columns, and these are the parameters which were checked, that is the HB level, the RBC, WBC and platelet count of blood. And now it has been arranged in again it has been classified as the first day data and the 30th day data. And now it is in a more presentable form, it is in a concise form, and here we will be, the data is easily accessible also. So that step is called as classification and tabulation. So we have classified first these 3 individuals, and then we classified the parameters, and later we classified them into the time period, that is day 1 and day 30, and finally we arranged them. So the objectives of classification are, we can make data accessible, more accessible than we write it in a raw form, and it is very comprehensive as well as attractive. We can compare between the two. This was the raw data which we classified. So this is more attractive and comprehensive and in a condensed form, and we can also ensure that if there is any error, we can detect it. If there is any error in the observation, once we put it into a table, we can easily detect it, and we can also make every possible use of the data. That means from this table itself we can just check whether the HB level of Sam has improved. So here we can see that it has risen up to 14.2. In the case of Anita also, you can see there is increase in the HB level. So from the table itself we will be getting every possible observation. So these are the objects of classification. Now the types of classification, it may be chronological, geographical, qualitative or quantitative. Chronological is when we arrange data according to the order of time. Geographical is when we arrange according to geographical regions. Qualitative is based on certain qualitative attributes, and quantitative is based on certain measurable attributes. So we will go through examples. So first is chronological, where we arrange data in either the ascending or the descending order of time. So here I am checking the concentration of a chemical named bicalin in a tissue cultured plant callus when the callus is treated with a chemical which is known as methyl jasmonate. So in the presence of a chemical called as methyl jasmonate, I am checking how much of bicalin is produced every week. So my study is of duration 3 weeks, and I have used this methyl jasmonate in this plant callus to increase the concentration of bicalin, and I am just checking, and I have just tabulated the data. So, here you can see this is the plant callus which is not treated with methyl jasmonate. This is the plant callus which has been treated with 25 micromolar of methyl jasmonate. This is the plant callus which is treated with 50 micromolar of methyl jasmonate. And now, in the first week, the bicalin concentration in untreated sample is this, the bicalin concentration in the treated sample is this, and the bicalin concentration in the double dosed treated sample is this. The next week also I take an estimate, I take the concentration of bicalin. So, here I can check whether it has increased. In the third week also I have collected the data. So, the entire data collected by me has been arranged in the order of time. That is what is called as chronological classification. There are many biological studies in which we can chronologically classify data. Say for example, the insect population in the pre-monsoon months, the monsoon months and the post-monsoon months. They are all examples of chronological data, chronological classification of data. Next is geographical classification. That is here in the table, I have shown the average annual rainfall obtained in Kerala and Punjab over 10 years from 1971 to 1980. So, here this is not at all geographical, but it is also chronological, where the time starts from 1971 and ends in 1980, and I have classified it according to the geography, that is the rainfall obtained in Punjab and the rainfall obtained in Kerala. So, this is what is called as geographical classification of data based on geographic zones. Suppose I am collecting the insect population in my area and my neighboring area, or I am counting the bird population in my district and the neighboring district. They are all examples of geographical classification of data. Next is qualitative. Qualitative means we will be just choosing a character whether it is that or not. So, it is usually divided into two, whether the male or the female, whether deceased or not deceased, like that. So, since it branches into two, you can also call it as dichotomous or simple classification, where here you can see the COVID cases in the month of March, 10th March, 12th March, 14th March and 16th March have been given here, and this red line represents the number of females who are affected and the blue line shows the number of males who are affected. So, here I have just distributed the data based on sex, that is I have divided it into male and female and thereafter plotted it into a graph. So, this is called as dichotomous classification, where we just take into account certain qualitative characteristics, and usually they will be dichotomous, that means one or the other. Next is quantitative. Quantitative is based on certain measurable characteristics. So, here I have collected water from this much number of wells, which I have named as C, H, J, K from the place they were collected. So, I have collected well water samples, this much well water samples. I have collected around 10 well water samples, and first I have estimated the pH of these samples, then the hardness of the samples, then the calcium hardness and the magnesium hardness, and they are all represented in the form of a table. So, they are all measurable characteristics which have been tabulated. So, that is what is called as quantitative classification, which is based on certain measurements. But all these are interconnected, because here itself you can see it is geographical as well as chronological. Here also there is some quantitative aspect. Here there are some qualitative aspects. So, they are all interconnected. Now, we will go to the tabulation of data. Tabulation is usually done in the form of a frequency table. So, what is a frequency table? It is one which represents the frequency of observations of the values of variable under study. So, we will just go to the study where I am counting the number of eggs laid by each bird in a population of 40 birds. So, I have taken a population of 40 egg laying birds and I am just calculating the number of eggs laid by each bird. So, I am calculating the clutch size of the eggs in a bird population with 40 egg laying birds. So, there are some birds who lay 8 eggs. There are some who have laid 9, some who have laid 10 and 11. No other number could be found. So, the number of eggs laid by these birds ranged from 8 to 11. And now, I am just counting the number of birds who laid 8 eggs. So, 1, 2, 3, 4. I have put 4 tally bars. And if it is 5, I can just put an oblique bar which shows it is 5. Thereafter, the counting will be easy. Now, again, I got 1, 2, 3, 4 and the fifth one. So, total I have got 10 here and then 4 more. So, the total frequency is 14. Now, the number of birds who laid 9 eggs. So, here I get 9. Then the number of birds who laid 10 eggs, 13. The number of birds who laid 11 eggs is 4. So, I could find that the maximum number of birds the maximum number of birds were found in this group, that means 8 eggs. So, the clutch size was 8. The highest the clutch size of highest frequency was 8. So, here these values which I got, so the variable was clutch size or the number of eggs in each clutch. So, here this was a small range, that means the values of my variable, the values of the variable which I got was within a limited range, that means it ranged only from 8 to 11. So, there was no need to group this frequency again. I just got 4 frequencies, that was 8, 9, 10 and 11. So, this is an ungrouped frequency table because I have considered all the values of the variable under study. Suppose I got 7 eggs, then I can enlist it here. I can just add one more row here. Suppose I got 12 eggs also, I can add one more row here because it is within a small range. So, this is called as ungrouped frequency table. Now, we will go to a grouped frequency table. So, if the set of data values is vastly spread out, that is if you get a big range of data, then you have to go for a grouped frequency table. So, here what we do is we will categorize the values obtained in different class intervals. And what is a class interval? It is a specified range within which our data value falls. That is what is called as class interval. So, here we will go to this example where I have studied the length of fish hatchlings. I got 35 fish hatchlings and I am calculating their length in millimeter. I got 14 hatchlings who were in a size range from 0 to 3 millimeter. I got 6 hatchlings who were in a size range 4 to 6 millimeter. I got 12 hatchlings who were in a size range 7 to 9 millimeter. So, here instead of putting the frequency as 1, 2, 3, 4, 5 like that, I have just classified the frequencies in class intervals. I have categorized the frequencies into class intervals. That means the individuals of size range from 0 to 3 millimeter, then from 4 to 6 millimeter, then from 7 to 9 millimeter, then from 10 to 12 millimeter. That is what is called as a class interval. So, this is a grouped frequency table where I have marked the frequencies. So, this is the difference between an ungrouped and a grouped frequency table. Now, what are the steps to construct a frequency table? So, suppose I get a data. I have studied 20 insect larvae and I am counting their length. Just as in the previous experiment, I calculated the length of the fish hatchlings. I have got 20 insect larvae and I am calculating their length in millimeter. So, this is the data which I got from these 20 larvae. I got 2.2, 2.1, 0.8, 1.6, 2.6, 4.6, 1.9, 3.0, etc. So, these are the values which I got from my study. So, first I will find out the highest value among all these observations, and that is 4.6. So, 4.6 is the highest value. Then I take the lowest value, and among all these values the lowest is 0.8, and now I calculate the difference. So, there is a range of there is 3.8. So, the range of values which I got is size of the range of values which I got is 3.8. Now, I have to take the width of a class interval. I have to determine, now I have to arrange these values into different class intervals. So, first I have to determine the width of the class interval. So, suppose the width of my class interval is 1. That means every class will begin with a multiple of 1. So, the first class we will start with 0. The second class will be 1. The third will be 2. Next is 3. Next is 4. So, here the starting values will be multiples of 1. And the first class I can start with 0. So, I have determined the width of my class interval as 1. Now, the approximate number of class intervals I can have. What is the difference between the highest and the lowest value? It is 3.8. I divide it by the width of the class interval. So, 3.8 by 1, that is again equal to 3.8, which can be rounded to 4. So, when I group this data, it means that I can get approximately 4 class intervals. Even if the number goes to 5, there is no problem. So, usually the preferential number of class intervals is between 5 to 20. So, here I can have 4 or 5, and so I have fixed the value to 4. That means I have divided the difference between the highest and lowest value by the width of the class interval, the desired width of the class interval, and I got a value 3.8 which I rounded to 4, but it can also be if you want to increase the number of class intervals, you can just reduce the width of the class interval. If you want more than 4, you can just reduce this 1 to a smaller value like 0.8 or 0.5. So, if it is 0.5, then 3.8 by 0.5 will be approximately 7.6, and that when rounded to 8 you will be getting 8 class intervals. But now I have here confined it to 5, and now we will just see how the class intervals are arranged. So, the first I start from 0. The second class will start from 1, next 2, 3, 4 like that. Okay. Then what will be the other extreme? The lowest extreme, the lowest value of the class interval is 0, 1, 2, 3, 4. What will be the other? So, here I write it as 0.9, 1 to 1.9. 2 to 2.9, 3 to 3.9, 4 to 4.9. Here I have written 0.9. It can be 0.99 also because it is less than 1. But I have just rounded it to 1 decimal number because all my values, all the values which I obtain here is in 1 decimal point. So, I just confine it to 0.9. I can even write it as 0.99 if I get a value here, that is 3.09 or something. Then the class intervals can also vary. So, depending upon our data, we will determine the width of the class interval as well as the number of class intervals. The desirable number of class intervals, the recommendable number of class intervals is 5 to 20. So, this is how we arrange the class intervals, and then we put the tally marks. That means the number of individuals ranging having size ranging from 0 to 0.9 millimeter is only 1. That is, only this insect larva is falling within this size range. So, I put it as 1 here. Then 1 to 1.9. Here you can see 1.2, 1.6, then 1.9. Okay, so 3 insect larvae are coming within this size range, that is 1 to 1.9. Then 2 to 2.9. So, here we can go 1, 2, 3, 4, 5, 6, 7. So, I write it as 7. So, first we put tally bars and then we can cumulatively write it as 7. So, likewise we will arrange the frequency by first putting tally marks and then converting it to the number. So, that is how we make a class interval. So, once again, when we concise the steps to construct a frequency table, it will be like this. You have to first arrange the data in ascending or descending order. Now, down the upper and the lower values. The approximate number of class intervals, that means which is recommendable from 5 to 20, can be calculated as highest value minus lowest value of the data divided by width of the class interval, before which you have to select the width of each class interval. Then you start a class interval at a value that is the multiple of the size of the class interval. So, usually we start from 0 and the second class we start from that particular that width. Then you arrange the class intervals in the first column. In the second column you put the tally bars and in the third column you write the frequency. So, this is how you construct a frequency table stepwise. So, this formula will give you the number of class intervals which you can have. It is best if the number of class intervals falls between 5 to 20. So, to get that number you can just adjust the width of the class interval, just as I told you in this example. That is, instead of 1 here, if I take the width as 0.5, then I will get 8, 7.6, which can be rounded to 8. So, I will get 8 or 9 rows here, and the class intervals will change as if it is 0.5, here I have to write 0 to 0.4, then 0.5 to 0.9, then 1 to 1.4, then 1.5 to 2, like that. So, that will differ. So, that is how the data is arranged. Now, there is one more column which we can incorporate. That if we incorporate that column, then that table will be called as relative frequency table, because here this is the same table as the above experiment which I mentioned earlier. So, here I got frequencies 1, 3, 7, 8 and 1. So, the total number is 20 because I had taken 20 observations. So, 1 plus 3 plus 7 plus 8 plus 1 is equal to 20. What is relative frequency? Here I got 1 out of 20. So, it is 1 by 20 equal to 0.05. This is 3 by 20 equal to 0.15. This is 8 by 20 equal to 0.40. This is 1 again 0.05, and the total of all these relative frequencies will be 1. Here when you sum up all these frequencies, you will be getting the total number of observations. So, relative frequency table is a table representing the relative frequency or the proportion of the total number of items belonging to a particular class. So, here the proportion is 0.05, okay, or it will be 5%. You can write it as 5%, this is 15%, this is 35%, this is 40% and this is again 5%, in whichever way you can write. So, these are some of the points which we have to keep in mind while constructing tables.